All right, here are a few common mistakes from the probability quiz that I wanted to go over. And I think number two part of the problem was maybe it was just kind of confusing in what it was asking you. So it was really the same situation as number one that many of you did well on, but it wanted to know once you toss a coin and then you have this ABCD spinner and you spin it, what's the probability of obtaining a tail or a vowel or both? And so again, this or means add. So there's a couple ways to do it. One would be to find the probability of getting a tail in the situation, and then or means add, so plus the probability of getting a vowel. But if that could occur simultaneously, a tail and a vowel, I would have to subtract that overlap because otherwise the uh, tail and vowel situation is being counted in both of these scenarios. You could also do a tree diagram for this thing and be like, okay, here's heads, here's tails, that's half and half, and then you've got your consonant and your vowel that could happen second in each of these. And if you look up here, there's only one vowel out of the four letters, so you have a 3/4 chance of a consonant and a 1/4 of a vowel. They're independent, so whether you get a head or a tail doesn't impact whether you get a consonant or a vowel. And so you could either go this way and say, okay, well, the probability of a tail is 1/2 plus the probability of getting a vowel, we just talked about, well, that's a quarter. Uh, but what if you got a tail and a vowel? And so that would be this situation right here. And that means it already happened. It already got counted for the tail and it was counted in the vowel. So this half and a quarter are both taking that into consideration. So I'd have to subtract that event. It's basically the overlap. So if this were a Venn diagram, it would be that like here's your heads getting a tail, here's getting a vowel, and this would be getting both. And so that would be subtracting a half times a quarter. And so I'd have a half plus a quarter minus an eighth. And then if I got common denominators for all of this stuff, I'd have 4/8 plus 2/8 minus an eighth. And so that's 4, 5, 6 minus 1 gives you 5/8. And so if I did it over here, I'd be interested in a tail or a vowel. Well, this outcome would be I had encountered a tail. This outcome was a tail with a vowel. And because it says or a vowel, this outcome actually ended up with an vowel. I don't have to have a tail. I either need to have a vowel or a tail or both. So if I calculated each of these branches, this would be an eighth. This would be 3/8. This branch would give you an eighth. And any of these give me the situation. So I could have added all of these up. And if I added all those up, I would have ended up with 5/8. And if this was like a regular quiz and you might have been able to see problem one is you found this answer right here, probably getting a head and a consonant, I believe, which is just this thing right here. And most of you got that right at 3/8. So notice that what I'm asking in two is basically the complement of this. Getting a tail or a vowel is every possible situation other than specifically getting a heads and a consonant. So you could have also done 1 minus 3/8 because it's the complement of what you answered in number one, and that also would have given you 5/8. So several different ways to kind of look at that one. And now I'm going to have to erase because my next problem is hidden from me. So I do think that maybe the wording of that one led to a little bit of confusion, and it was worded a little bit. There's a lot of words, I guess is what I'm saying. It wasn't the wording itself. It was just that it was a lot of things that were kind of being asked for up there. So the second one, and this one was, I think, the next one in my classes that was missed most frequently. And you're trying to find the probability of B given A. So the formula, and this is in the formula packet for those of you moving on, is the intersection of those two events divided by the condition. So whatever's here is what goes in your denominator. And so if I can look up that formula, I can answer this question. So I only care about group A, so that's this circle right here. So anything that's not in this circle is irrelevant to me now, based on this conditional question. So A is all of this stuff in A, which is 0.3 plus 0.2. So my denominator is 0.5. And I want the intersection of these two events to be in my numerator. Well, that's this piece right here. This is my intersections at 0.02. So that would, or sorry, just 0.2. So that would go in the top, and that's the same as 2/5, which is the same as 0.4. So it's not as easy in this particular teaching mode to figure out why this one was so commonly missed. But that's what you do, especially with a Venn diagram. It's pretty quick. The condition over here, whatever that is, total in that circle goes in the bottom, and then the intersection, that overlap piece of these two events, goes in the top, and you simplify and you're good to go. All right, moving on. This is another one that is a conditional probability. Right here is the way I know it's a conditional probability. So if I were to rewrite this one, I want to find the probability of R occurring given that T occurs. So just like the problem a second ago, this is your condition. I am already starting under the fact that T has occurred, so I only care about outcomes out of the possibility of all the T's. So that is my denominator, and the numerator is the intersection of those two events. And so this is the probability of T right here. It's 0.7, so that's the bottom. And the top is the intersection, and because this says that these events are independent, only because they're independent do I know that the probability of R and T is equal to the probability of R times the probability of T. If that piece of information weren't in there, I wouldn't be able to do this extra calculation. So probability of R is 0.5, probability of T is 0.7. If I multiply those, that's 0.35, so that would be up here, and 0.35 over 0.70 is basically a half. 35 over 70 is a half, or 0.5. I can't remember how the answer showed up on the answer key. So again, that one is using this conditional formula and applying the idea of independence, allowing you to calculate this top piece. And now I have one more problem. There it is. All right, so I'm going to move this guy up a little bit. And this one, sometimes if you're not as familiar with the deck of cards, this one's a little bit tougher, but this is similar to the first problem. So you'll notice there's two problems that both cause similar levels of difficulty. I have a standard deck of cards. I want the probability of drawing a heart or an ace. So that means I want the probability of drawing a heart out of the deck, or means add, and I would be all set and done unless there are some aces that are also hearts. If there's an intersection between these two sets, then I have to subtract that intersection. So I would have to remove probability of a heart and being an ace. And we could do a Venn diagram for this as well, because there are some hearts that are aces, and we'll look at that. And so most of you that I looked at that got this problem wrong, you forgot this piece over here where you subtracted the overlap. So the hearts, there are 13 of the 52 cards are hearts. You have 4 aces in a deck, but the problem is one of these aces is the ace of hearts. And so I've counted that card in each of these calculations, and so I need to subtract the overlap, and there is one card that is simultaneously a heart and an ace, and that's the part that I think some of you didn't get. So oops. So 13 plus 4 is 17, minus 1 is 16 out of 52. And I would have reduced that because 4 goes into both of those, but I can't remember if the answer made you reduce it or not. And if not, you could also, in the non-formatted quiz, leave it to either of these or put it as a decimal approximation, whatever that might happen to be. So those are the 4 problems that were missed most frequently. And 2 and 14 are very similar. You have to subtract this overlap because there is an overlap. And 13 and 11 were both conditional probabilities that required you to know that kind of that formula and be able to apply it. All right, that's it. Hope that helps. If not, as always, let me know.